there's a much faster way to do this instead of just doing using the trig identity thing, or like turn this into sine 2x or stuff like that. We're going to utilize the bounds. And I guess an easier way to look at this is like if you were like, let's just focus on this and this, and you'll see why. So if we go ahead, just focus on those two terms, right? Here's what's going to happen. Or I don't, you know, I'm going to ignore the constant. You'll see why. I'm just going to show you a concept of this, right? So if I let this, like let's say let x equal, should be the other way around actually, x equal pi minus u. What's going to happen is this is going to become, well, I get negative pi here and pi here. However, sine of pi over u is just going to equal sine of u. Right? And so this is just going to be sine u. This is going to be, well, technically this would be like negative cosine u, but I can just put the negative here. But the thing is, this is just going to be equal to 0, right? And the reason is because this and this, it's pretty much like negative a of a, and then an odd function here. Whenever you see something like that, an odd function, this just goes to 0. So, and the reason why this happens is because these are periodic. Oh, I can't undo. But the period of these functions sort of cancels out to 0. So like this is going to cancel out. And same applies to here. You know, this sine x is going to make it cancel out to 0 because it's an odd function and it's period to 2 pi. So what we actually have is that this is just cosine 2020x cosine of x, and then plus 2020 sine square. And that's pretty much it. Here, this is nasty. But what you could do here, I guess you could just do like half angle identity. A half angle identity. I forget what it's called. That's where like you have that divide by 2, and then you sort of add. I actually forgot how it goes. It's like, and I need to add. Yeah, I need to add so that I can get 2cc because that's what I have, 2 cosines. So then this would be like, so so these are all cosine laws. So this is just, this would be like 2019 here, and then here, because there's a minus here, this would be adding, so this would be 2021 here. So I would be having, so because we're adding, this would be 2019x plus cosine of 2021x. Okay, so if you don't know where this comes from, this comes from the trig identity here, and this is equal to like cosine of a cosine of b minus sine of a sine of b. That's what these represent. So that's why like I can't. It's hard for me to memorize it. Even though it is faster that way, it's just hard for me to memorize it because I get mixed up with plus and minuses. So that's like my emergency method. Like if I don't remember, I'll just do that way. And then here, this is just, oh, we got 0.2 pi. If I can do that properly, okay. And then here, this is just 2020. You can just turn this into that. And then you just, at this point, you just integrate across, and then you're pretty much good to go. I do notice something. I will let you know this. This is going to go to 0. This is going to go to 0. And the reason is because when you integrate cosine of something, whatever, right? Just cosine, or whatever. I don't know why I wrote it like that. You know, just a cosine function. That's it, right? If you integrate this, you're gonna get whatever the hell junk, a sine function. A sine function. What happens if you input 2 pi and 0? This will always be 0. So, because of that, all I really have is just 0 to 2 pi, 2020 divided by 2, that's like 10. And so now my answer is just 2020 pi. And that's it.